All right, I'm not going to spend a whole lot of time on this one. In fact, I'm going to cheat pretty badly here. I'm going to take a quick screenshot of the example problem that's given on this topic in your textbook, and then we'll just talk our way through it. And that's really all I want to get out of this particular video. This problem reads like this. A food service company has company operated restaurants, franchises, and food trucks. The revenue and expenses for 3 years for each of these categories are shown in the spreadsheet below. Use matrix algebra to determine the yearly profit from each food service category. So what we're going to be looking at here is, it's a spreadsheet, but each sort of cluster of cells here really looks like a matrix to me, and that's exactly how we're going to interpret this. Notice that when we do set up our matrix for this problem, what we're going to have to do, our matrices, is we're going to have to make sure that the entries for each year and each category are the same. In other words, if I have 2015, 2016, and 2017 in this matrix, I want them in the same order in this matrix and in this one. And the same thing down the side. I have categories, restaurants, franchises, and food trucks, and I want those in the same order in the other two matrices as well. So what I'm going to do now is literally rewrite just the numbers from each of these clusters of cells into a matrix, and then we'll take a look at what it means to use those matrices to figure out what the revenue is, or what the profit is. Okay, on this screen I've got the question, the problem again, and then I've just shrunk it down a little bit, and we're going to work out the answer down here on the bottom right, this part of the screen down here. And a little at a time, we won't need this part of the screen anymore. So eventually I'll make this go away. Really, the key here is just to recognize that, as I said on the previous slide, the entries for 2015 all have to be in the same position, 2016 and 2017, and each of the categories has to be in the same position in each matrix. So what I'm going to do now is rewrite the data in each of the spreadsheets into some matrices, and I'm going to call, we've got a matrix here for revenue, or a spreadsheet, or a piece of a spreadsheet for revenue, one for production, and one for advertising costs. And recognizing that revenue is total income, profit is what you have left over from your revenue once you've paid for any expenses, in this case production costs and advertising costs. So we have the sort of equation, if you will, in general terms, that profit is equal to revenue minus cost, and I'm just going to call that C for production costs and A for advertising costs. This is really all my cost, right? And I'm subtracting all of that C and A from my revenue. My revenue is my total income, and my profit's what's left over once I've taken all of my costs away from my revenue. Okay, so my first matrix here is my revenue matrix, and that has entries 11,000, 9,500, 6,250, and those now correspond to the first column in my revenue matrix, R for revenue. My second column is 10,500, 10,000, and 6,000, and those correspond. And then 11,750, 10,250, and so on. So those just correspond to the entries in the spreadsheet. And then I'll do the same thing for the production costs. That's going to be my matrix C. And you can see that here I have 3,500, 3,000, and 2,500. That's the first column. Second column in my production costs spreadsheet corresponds to the second column in my matrix, and so on. And lastly, I'll do the same for my advertising costs. So there's my third matrix. So this piece of the spreadsheet corresponds with this matrix, A for advertising. I think I would have called this P. Well, no, P is going to stand for profit, isn't it? So we had to find a different letter for our production costs. So those are my three matrices. And basically, really all I want to do now is I want to associate the matrix of this these operations, right? This matrix arithmetic with these matrices here. I know that my profit, which is what I've been asked to find, determine the yearly profit from each category. I've been asked to find the profit, and I know what the revenue, the production, and the advertising costs were. So all I need to do is set up the matrix arithmetic to do that. Here's my equation. The profit from the profit for the company is the revenue minus the production expenses and the advertising expenses. So there's my matrix equation. Up here, I used the distributive property of matrix addition, which says that I can write the a scalar times the sum of two matrices as the sum of the scaled matrices. So R times the matrix A plus B is the same as the scalar times A plus the scalar times B. And all I did here was use the scalar -1, and I undistributed that so that I've got it in parentheses there. I'll put it in brackets, but in parentheses. So that's the same as the equation that you see down here. Okay. So now the next thing I want to do is to interpret that equation in terms of the actual matrices. So I'm looking for P, and I know that P can be written as R minus C minus A. So let's write out each of those matrices, R, C, and A, and do that matrix subtraction. Okay, so this is matrix R, and from that I'm going to subtract matrix C. That's matrix C there. And I'm also going to subtract matrix A. And you'll see that when I do this arithmetic, I'm going to get entry by entry 11,000 minus 3,500 minus 2,500, which turns out to be 5,000. And then let's just pick another one randomly here. 10,250 minus 3,000 minus 525 turns out to be 6,725. And if I do that for each entry, I get this matrix, which is matrix P, P for profit. So I'll just say that's equal to P. And what this now tells me, because each entry in the individual matrices here corresponded with a given year. So this was to look back at the original problem here, 2016. 2016, the revenue was $10,500 from company-owned restaurants. And let's see, where am I? So $10,500 income, revenue from company-owned restaurants, but they had $3,000 and another $3,000 worth of expenses. So what you're left with is $4,500. And so now I can look at this final matrix, this matrix P, the one for profit, and I can interpret it based on where the data in the original, the data in the matrices came from. In other words, the yearly profit from each category can be read from the final matrix. The profit from food trucks in 2016 was $3,600. The profit from, let's see, if we have food trucks in 2016, so it's the middle column, the 2016 column, and it's the revenue in 2016 from food trucks minus the production costs in 2016 from food trucks minus the advertising costs in 2016 from food trucks, for a total of 6,000 minus 2,500 minus 150 is 3,600. So the profit is $3,600 for food trucks in 2016. So I know that's a pretty pedestrian example. There are lots of other examples of ways to use matrices, matrix arithmetic to solve various applications. But frankly, matrix arithmetic, matrix operations are really very powerful. And I just don't really feel like I want to spend a whole lot of time on this really basic one, because we've got a lot more to cover and things that are going to get a lot more interesting, and you'll see a lot more powerful work come out of matrices once we have a little bit more under our belts of what we can actually do with them. So I'm going to leave it at that for now. Pretty deep cheat there from just using the example in the textbook, but I really feel like that's enough for this particular video.